Assalamualaikum warahmatullahi wabarakatuh. I'd like to introduce myself. My name is Rizaldi Taufik A and my partner Aqshal Arlian. From the assessment that has been given, I chose the journal entitled Implementation of Driving System Design on ROPAX GT with Electrohydraulic Servo Actuator by Hafid Mardiansyah. From this journal, there are several important things that are in spotlight. The first, in the steering system. Steering system is the system on the ship that used to change and determine the direction of the motion of the ship. But the straight and the turning direction of the ship, the rudder is replaced at the rear end of the hull or stern behind the ship propeller. The working principle of the ship rudder, namely by changing the direction, the fluid flow which results in the change in direction of the ship. How the ship rudder work, namely steering driven mechanically and hydraulic from the bridge by moving the steering wheel.
Then there's the steering. The steering is a large form of the several tool use. Another important part is driving. Ship steering is an important part of running a ship. Steering a ship is different from driving other vehicles and must require special skills to use it. This has made ship control an important part of the world of shipping. Safety is also the responsibility of that way of driving.
And in the process improving in the steering system, there are several types to operate it. One of them is the with hydraulic, which is also an important part of the journal. Hydraulic is the liquid as an introduction. Later, the energy generated from the hydraulic system generate mechanical energy. In the ship hydraulic steering system is used to move the cumulative on the ship. In the section, improvement will be made to improve the ship motion.
In the process of improving the ship's steering system that use a control valve to move the rudder, in this process, the design will be changed using electrohydraulic servo valve, which will be tested using software. Electrohydraulic servo actuator and hydraulic systems that run electrically by adjusting the valve opening and closing of the system. Then
And
we can the next slide.
okay, what was discussing in the present in the journal? Three important things will be discussed in as follow. The first is steering system. Steering system, as mentioned in the previous slide, this system is a very important part. This system regulates the course of the ship and affect the safety of the ship in accordance with the problem that occurred on the ROPAX 300 GT ship. There was a problem with the steering system. This research was conducted based on these problems. The problem that occurred on the ship was due to rudder system that was not running optimally, which resulted in the two rudder operating out of the synchronized. The unsynchronizing between two steering wheel with another can be caused by several things such as unequal fluid flow between the steering gear or design of the ship, steering system that need to be refused. Therefore, the fluid control valve is needed to shift steering system so the fluid is circulate to each component of the hydraulic cylinder can be evenly distributed.
In this case, it greatly affects the ship maneuver, which is also an important matter discussed in this journal. Maneuvering is the ship's ability to be able to make movement, change positions, and speed under the control of the ship's operator as a result of the steering system. There is a difference of 15 until 20 degrees in the movement of the rudder, which greatly affects the maneuvering of the ship and cause disruptions of the ship's motions. The shipyard does provide a counterbalance to the steering system, but there is still a difference in steering angle of up to 15 degrees.
Number three, refinement the steering system design. In this case, we take the initiative to conduct a review of these issues. In the problem, the ROPAX 300 GT rudder system use control valve as a device to regulate the amount of the fluid that will enter the hydraulic cylinder. But by using the control valve on the steering system, there is no synchronized between one rudder and the other. So it must be used the electrohydraulic servo valve. The electrohydraulic servo valve is a control system component designed in a such way that the output of the system is accordance with the desired input so the hydraulic system is evenly distributed and can be controlled so that the movement of the two steering wheels can be the same. This refinement process goes through the state of deterministic resistance using Hall-Thorpe method with mixer software and followed by the force of the steering system and calculation of the hydraulic system to use after testing calculating with the software. Total resistance value is 63.9 kilonewton and from the calculating steering lift force there is a 50 50,000 newton. The hydraulic cylinder design slow rod diameter is 32 mm and piston diameter is 37 mm and the stroke length is 350 mm. Simulated result so the fluid sim hydraulic steering system software take 26 seconds move from 360 port left and to 350 starboard right. Next slide.
Okay, for the next slide is talking about the method that we use. In this study, the method used on the ship is electrohydraulic servo actuators. The system is widely used because of its great power, high accuracy, and fast response. This capability is utilized in jobs such as lifting, checking, and forming. As a programming system that is run by the system should still be supervised uh, when it working because the electrohydraulic servo actuators have a high nonlinearity properties such as friction and internal leakage. Frictions can cause several problems such as tracking error, limited cycle, and poor stick slip movement. This allows for instability in the AHS system.
In the study also use software assistant, namely Maxsurf and Fluid Sim Hydraulic. The use of Maxsurf to calculate the resistance on the ship is based on the method chosen, while the hydraulic fluid sim in is used slide number 5 is a method we choose has its own advantage and disadvantage. And here are the advantages is high accuracy, great strength, and fast response. And disadvantage side friction and internal leakage. But after we considering the advantage and disadvantage, this method is quite effective and efficient to apply.
Yes, and then we come to the summary and benefit. The summary, based on the simulation results through fluid sim hydraulic software, the steering system takes 26 seconds to move from 35 degrees port to 35 degrees starboard. Then the benefit, the results of the study can provide a reference and basis for consideration of the steering system design using the electrohydraulic servo valve to be applied in the ROPAX 300 GD ship steering system.
Okay, we think that's all our present.